So that's all from my side. I pass the word to our today's speaker, and I hope you will enjoy today's lecture. So,
Thank
Roman.
you. Thank you. Hello everyone. I'm Roman. I'm Roman Babkin. I'm lead data scientist at GlobalLogic. Pardon. I'm a PhD in theoretical physics, and I basically work with all that machine learning stuff. So I have almost 8 years experience in data science, in industrial data science, and more like 15 years in academical research involving machine learning stuff as well. So today I want to show you I want to speak with you about some very, from my perspective, very important part of the AI, current AI. And basically this lecture is based on my own knowledge, on my own experience. And when I realized some parts of this, I realized everything uh, what is AI and how to work with it and how to not to work with it. So I suppose when the lecture is over, all of you would know, would feel like would leave this lecture with one strong idea that why I want to tell you. Okay, sharing sharing the screen, just a second. Uh Tell me if you see it.
Yeah, we can see it.
Oh, great. Okay, cool. 1 second, I need somehow to adjust it. Um, okay, no worries. Um, okay, let's start. The name of the lecture is like we have lots of names of this lecture, but I do like this name as Does AI, artificial intelligence, really understand us? Is it? Does it? So let's think. Let's go. Okay. The agenda of our today's lecture would contain 6 parts. They are big, relatively, but they have their own ideas inside. And I just want to explain in a very, very simple way how does AI, especially the text generation AI, work, and what are the main structures and how can we use it. So let's go. So couple words about generative AI, and then we will dig into the large language models like text generation models. So what is the generative artificial intelligence? Uh, Generative artificial intelligence is a form of artificial intelligence. Let's make this because it's a very from like I would say it's a um more like marketing word, the AI, than it is. From like data scientists prefer to say that it's machine learning or some data science or even statistics, but AI it's more like more very fluffy word, let's say. So this is a form of AI that uses existing data to generate something similar based on this data, or not similar, but based on this data. So generative AI use probabilistic frameworks. It learns patterns, it learns trends, it learns structures and features from the training data that you put. If you put the data with non-structures or unstructured data, or the data that is very generic, general, and the data is not enough, it will not learn. Typically, in most cases, when we say AI, we always say deep neural networks, because deep neural networks are the very commonly employed building blocks of the Gen AI, because of their structures, because of their ability to learn a lot and to find a very deep, um, deep, uh, deep structures inside. And basically, one of coolest features of the generative AI models, as why do we use it, is when we create one model, we can, it's called a pre-trained model. We can retrain or upgrade it, fine-tune based on different data to get something different, similar or different, whatever. If you create a model based on kitties or dogs, you can make a model based on this that will recognize uh cars and create cars. And there are like majority of like there are only three types. Majority of types is three: sound-based, visual-based, and text-based generative AIs. There could be like 3D models based and so on and so forth, but typically when you say generative AI, you in 99% cases you would find one of those three. And nowadays the biggest part of it is a text-based. Like when the ChatGPT appeared, it was like a shock and so on. uh, I have to admit that there are some concerns about the generative AI. So the first one is they might not be accurate. You shall always know and remember that all the models that you use might not be accurate. Recently, I read that ChatGPT gives inaccurate responses in 50 or 54% of all the cases. So it's insane. So don't trust it. Uh, Use it, but not trust. Lack of transparency, because it's a black box. We don't know what's going on inside, and we can't even imagine, understand how does the AI get this result. It might be biased. So when you train the data on some, when you train the model on some data, it might be biased. It might have something inside that let's say if you train on kitties and you try to predict dogs, it will never predict a dog, but it will predict a kitty. It may contain intellectual property. And we shall always remember that when we use our own data to feed in the ChatGPT or whatever, we might expect that this data will appear in the training loop. Cybersecurity, that's about it. Our data might be there. Or someone generates some so-called deep fakes and so on. Again, it's a fraud, everything that. So you should remember that in our world, when these models are extremely accurate in generating, let's say, a visual content, this visual content might be fraudulent or fake. And sustainability, when we run every model, we pay with our environment, because all the models, they acquire a lot of energy, they consume just a lot, like I don't know, horse drinking a water. And it means that we need to spend a lot of our energy resources to feed in these in these models. Okay, few words. Everything I said, machine learning means that the AI is a part of the machine learning. Just a very quick explanation. What is machine learning? Machine learning is a approach where you have uh when you have an object, you transpose this object into some digital mathematical representation. You have something called model, and this process that feeds this data in this model. We have this update loop. It's called training. So some formulas inside some matrices, they learn this data somehow, and at the end we have a mathematical formula, very complex mathematical formula, so-called model. And this model can be used for different answers. Let's say we use a question. What does it mean, question? We can say ask a question, real question, or put some image or whatever. So we can interact with this model to get something out. So this is a very, very simple concept of machine learning. So, and this concept is a concept of AI. Also, let's go deeper to the large language model. So basically, we've talked about these three types, and I want to concentrate on the text-based language model, generative AI. I want, like every one of us have heard about the large language models. I will not explain what are they, what do they contain, the architecture and so on and so forth. I just want to explain briefly their main parts for us as users. Um, these parts can be utilized by both engineers and just pure users of large language models, because these concepts, principles, they give you possibility to understand how does it work and how can we use it. So the first principle, I think I know that everyone knows that, is a tokenization. So I don't know if we like I know we've all of us we've heard about the tokens, but what are the tokens? Um, Tokenization is a process of breaking down the text into small, very simple parts. A simple part, the basis part of the language, is a word. So each word in a language, we can decide that this is a token. But in large language models, not so simple, because typically the token is a word. But if the word is complex, like here, unfriendly, uh, each token, like this word can be represented as 3 tokens. You can see this sentence can be split into tokens, and each symbol is a token, and there is one more def token as end of text. So when the model sees end of text, it stops. If we have abbreviation, it will transpose this abbreviation into something that it knows. When I created this, I realized that possibly NASA is a word. It can be considered as a token, not as a different symbols. However, if we talk about smaller models than GPT, it might be concerned as different symbols. It's just for representation. Okay, so when we put some text, first of all, we split it into tokens. The second part is like idea is context and attention. These are two different things, but they are based on something similar. So context is a segment of the input that explains some background. When I say mother, it doesn't have any context, but when I say mother loves her daughter and so on, there is a context outside. So the context, it belongs to each particular token. So each token has its own context. Or if we talk about the prompt context, I will talk about it later. In this case, the context is some part of the text that explains some prerequisites. So I will explain later. But in this case, for the let's say for the word fox, there is a context, a brown, and it jumps. Maybe quick brown fox jumps. This is the context, and something very, very far from this word might not be considered as context. And there is one more thing, attention. It's a mechanism that is pre-built and the large language models that allows model to focus on some specific parts. So when the model learns this word, it focuses only on the words that are in the context that for this word. So basically, I don't know, end of text is not a good context for this one. So attention to the end of text is less strict than the attention to the closest words. Here I put several simple types of attention. When we learn, let's say, from left to right, there is attention like from the previous words, from the left, previous next words, just immediately next words, or the words after. So there might be different algorithms and more complex model. The more complex model is, the more deeper attention it uses. Okay, next one. Um, it was very fun when I heard about it first. It was like 2 years ago when it was just a new one. The temperature. What does it mean? So the temperature is some kind of parameter that controls the output. So in a few next slides, I will explain, like in a slide or so I will explain how does the large language model generate the answer. However, the temperature is the parameter that helps to create this, let's say, next text. And basically, temperature is a parameter of randomness. If I put the temperature, very high temperature, I will get very random text. If I, let's say, put 100 temperature, so it, or I don't know, 36 and 6, I don't know, something above 1. So I will explain the nonsense. I will explain the useless text. But if I put the temperature lower or even to 0, I will expect that the text will be strict. It will contain only like from time to time, if I ask the same question with 0 temperature, I will get absolutely the same result. So I swear myself not to include the formulas into my lectures because each formula decreases the number of participants by 2. But sorry for that second part of the participants that will will not join. I had to put this because how can we understand the temperature? The temperature is just a parameter in the formula, is in the softmax that helps us to understand the probability of each particular token that we want to put. Imagine that when the LLM wants to continue the text, it decides which word should be next, and it gathers it calculates the probability of various words, and then picks up on the best one, the most probable. And this parameter controls this split, and if we put very high temperature, all the words may appear with the same probability. And so you can pick, instead of dog, you can pick a refrigerator. So high temperature is suitable when we want some creativity, when we want to create a new text, or when we want to rephrase the text. Low is suitable when we want to use when we read documentation and we want to be very, very precise. We want to have exact same text as there. Or if we want to have use some formulas or some tools based on LLMs, I will explain in my next lecture how to use this. So in this case, if in most cases here we put 0 because we don't want some randomness. And when you think about the chatbot, let's say, it can be balanced middle. 0 is a robot, 100 or even 1 is a nonsense, but 0.5 temperature is something like a human being. So basically, when we right now I'm speaking and I'm trying to find some words and I find synonyms, and it's the same to middle temperature. Okay, very, very important part is the embedding and the vectorization. So basically, this one is the part when I told you here the digital representation this is it is a very critical part um, of all the machine learning process. When we represent some human objects, human something, into mathematical words. And in this case, uh, embedding and vectorization is what we are talking about. So how does LLM understand the text? Not understand, but get the text, let's say. Okay, imagine I have, how can I represent words as numbers? I can take a vocabulary and just put each in front of each word. I can put the integer, the index of this word. Let's say A is 1, AR1 is 2, and so on and so forth up to Z. But it will not represent um, the relationships between words. Let's say cat and dog, they have some relationship, and the cat and the spaceship may not. I know cats, they were in spaceships, but nevertheless, there is less relationship between them. So this indexing will not give you this idea, but the embedding will. So how does it work? Let's say we can categorize words. Imagine I can create here 6 categories. If it's a living being, if it's a human, what gender does it represent? Does this word represent? Royalty, is it a verb or it's a plural or not, or single? So, and in this case, I can put some numbers representing this particular word in this particular sense. So cat, is it living? If it's a Schrodinger cat, I don't know. But if it's a cat, it's definitely. In most cases, definitely. Is it human? Um, Close to 0. Cat woman, maybe because of the cat woman, we have 0.1. Gender, again, it might be male or female. Royalty, I've never heard about the royal cats. So is it a verb? No. If it's a plural, no, cat is a single, and so on and so forth. You can represent it. And lots of models, like commonly used model text embedding ADA 0.02, it has 156 such kind of 100, no, I'm sorry, 1,500 with something, such kind of representations. So each word can be represented as a very long vector, and each step of the vector represents this particular feeling. So, and this is embedding. So you can embed, you can represent the word as the vector, and you can represent the text as the vector. You can represent an image as the vector, because if you see the Caton image, again, here it is. So what will give it to us? In our case here, in this case, we obtain not the word, but we obtain the 6D, 6D dimensional space. And in this space, we can put the point that explains the vector, sorry, that explains this particular word. And like if I project this 6D space into 2D space, I will see that the cat and kitten, they are quite close to each other. Dog is far but close, but houses is very, very far. And this gives us the possibility to understand, to feel the relationship between vectors by knowing the similarity, or some by applying some linear algebra on these vectors. We can understand if this vector is close to this one, and if this vector is far or not. Also, it gives us possibilities to group some words by some category. So let's say we have a man and woman, king and queen. And if we project it into 2D space, we would see that the king, uh, uh, the relationship between king and queen is dissimilar that man and woman. And king and man, they are quite close to each other from one. So like there could be multiple correlations, multiple projections, and so on and so forth. However, this one, this representation gives the model ability to work with words as the mathematical formulas, mathematical objects. Let's go next. Why do we need this? How does generative AI, large language model, use all that? So, and here comes the main idea of the large language model and what I want to pitch. So the text generation. I'm talking about LLM. The generation of the image, let's say, or sound might be explained in the same manner with the different factors, but nevertheless, the idea is absolutely the same. The text generation is on a token basis. So how does it work? Let's say we have a first word. We start with the first word, the. And then, based on this word, now this is a context. The model tries to predict the next word, next token, sorry. And let's say in our very, very small world, we have a quick, sun, and bird. And each of them have different probabilities. And let's say the quick one is the most probable, 0.8. So we reject all that and we put the quick. Now our context becomes bigger, the quick. Oh, cool. Now what will be the next token? Probably brown, and so on and so forth. And now we have a context window. Let's say we do not put here all the words. Imagine that you have a very, very long document. We don't want to put it, but we have some context window because we have the attention steps, if you remember the previous slides. So the quick brown or jumps over the. So in our 3 words context window, we don't remember what was previous, but based on this, we try to predict what will be the next. And so on and so forth, up to we get this token. When this token, end of text, has the maximum probability, it stops. And here you are the result. So the text generation is just a generation, recurrent generation, recursive generation of the next token based on previous batch. So this is it. So this is the idea of all the large language models, and basically the kind of idea of all generative artificial intelligence. Okay, this is the text. When I generate a I don't know, a song or a document, but what if I ask a question about something more specific? Let's say if I ask a question about the astronomy or whatever, it might be it might be pre-trained on this data because like GPT-4 is pre-trained on the whole internet and it definitely knows something about astronomy. So and it will know the some probabilities between some words and some words, some relationships. However, if I ask a question about math, like what is 15 plus 27 or multiply by that, how does it work? It acts similarly as the same to text generation. It can't do math. What it does is just generate text. And in this case, it splits this question into tokens and tries to predict each next token. After that, so what is the 15 plus 27? And after that, it will generate new tokens. And unfortunately, it will not calculate this. It will represent it as a tokens and try to predict the next token. And I I hope it will be 42, but in most cases, no, not in most cases, but there will be a very long list of other answers, and 42 is not the only one. That's why I say if we put very high temperature, we will see the answer not 42. And basically, this result is based on all the knowledge that the LLM has. If I ask to multiply a very long float by very long float, and it never heard about those floats, it will give you a wrong answer because it has never seen it before. So pure large language models, they not like first, they may not produce accurate results at all. And the second one, they may not provide accurate results for complex mathematical problems because they do not perform computations. They just try to predict what's next. It's like a very intelligent student that doesn't want to calculate, but he just uh, uses his I don't know, dices or a coin just to predict what will be next on exam. It's a pity. So you will like you have to always know that the LLM, they predict just a text. Just more simple remark: the ChatGPT is not a model. The ChatGPT can do some math because it uses the model and some tools around, and those tools can do the math. In some cases, maybe GPT-4 can do this, 3.5 cannot. Okay, let's move on. Context matters. So here we've talked uh, about how does it work, but the main idea of fine-tuning, the main idea of the man who creates this LLM, of a data scientist, is to make as accurate as possible. So to fine-tune the model or somehow make it give probabilities to more valuable words. So, and in this case, context matters. So in my one of the previous examples, I showed you the first Z, yes? And basically having the context Z, you will never get what you want. Like here, like it was a 3 months ago, based on 3.5, I tried that. I tried this prompt, and I explained what does it like. What do I need from it? And I said, considering this temperature, finish the sentence, and I uploaded all that parts of the sentences, and I said, give me the sentence 9 words long. So having Z, I have the sun cast a warm glow, blah, 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 blah. Nothing what I want. Now I add quick, the quick. Now it says quick brown fox job because basically because the quick brown fox, it's like a very, very simple and common sentence in the internet. That's why it gave me this, but not exactly. Given more and more complex, at the end, I found that I need this much data to get the correct answer. So the context matters. So more data you give it, more data more context you feed in, the better results you obtain. Next, when I say context, you put, I mean prompt. So let's discuss what is the prompt, because the prompt is the main tool that we use to interact with the LLMs. So the prompt is the specific input, the text to the language model explaining what do we want from it. It should contain some context, it should contain some structure, and basically the idea of LLM is to finish this prompt, to continue this prompt. And basically the prompt is the instruction. Like here, can you please write a paragraph summarizing the key features, blah, 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 of the solar energy and so on. So this is a task to the model. Here we explain what do we want. We give it some context, just not just a pure paragraph, but about this. Give some we give some specific details like environment impact and so on. And we explain the probably we explain this tone like please can you, and it will answer in the same tone. So having these, like basically the prompt when I ask someone about something or when I explain someone something, I use the same, but I use those prompts with the people when I ask give me what, and so on. So I need some context when someone asks me something. So in this case, prompt is basically the tool that we use to explain the LLM all that we want. Um, I have just a little time, but I just want to consider stop at this moment, and I have a set of maybe rules, but maybe um, mm, parts of the prompt that I typically use. So the prompt should be clear. It should go straight bullseye. You should have a context. Um, Sometimes we can use some so-called complete sentence. So when we just stop a sentence with the three dots and we are just waiting the LLM to finish it. It's a very good approach how to improve your prompting and how can you improve the algorithm, because the main idea of the LLM is to continue the text. Instructions give more instructions, and if you want, if like consider it as a little child. If you say, "Hey, please go and give me the beer from the refrigerator," it will not understand. You just need to explain the boy or the girl what exactly do you need. Details, more details, better. Less details, what you put, what you get. Style and tone. You can play with the style and tone to get the same style and tone at the result. I will show you in the next slides. Examples. It's very good if you give examples to your code. Let's say I want this, do this, for example, this, and it will it will boost up your result. It will make your result as accurate as possible, like more accurate, let's say. Length. You can specify the length of the output. Let's say if you ask what will be 2 plus 2, it will give, oh, sure, I will give you the answer. The answer will be, I will use the calculator and so on and so on. But if you say, what is 2 plus 2? Give me just one simple digit. It will give you just 4. That's all. So you can use that. Open-ended or specific. You can ask the question, just specific question, or you can give the possibility to for the LLM to think, to get like when you see the thoughts of the LLM, you might find something interesting for yourself, because the answer that the LLM gives to you considers lots of per steps, and if you see these steps, you might really understand more of what you're asking. Question format. You can ask a question and like question. You just literally put question, answer, and 3 dots after answer. Politeness. So basically, if relevant at polite phrases. So don't be rude, because like think about future. We don't want to have a angry Skynet. Just say thank you to LLMs, and LLM will respond accordingly. Um, let's go to examples. I've talked about a lot about this, and let's use this. The first example is a style. It's a very brilliant idea. So I asked the 3.5 turbo. You are 10 years old girl. Explain me what is the quantum mechanics. And yes, it gave me the quantum mechanics explanation, as it was my son or daughter. Or if you're a 60 years old professor in quantum mechanics, explain me what is that? Oh, sure, please. And this was my professor. Really, he was. So using just different words in a prompt, you will get the same idea but explained in a different styles. I played with the Tarantino or I don't know, different cartoon characters. If you are Bugs Bunny, just explain what is quantum mechanics. It's insane, and I love it. The next one is the example of instructions. Um, we can utilize the LLMs not only for just question answering, but for like as the part of the tool, as the part of our computational steps. This is the like first step for my future lection next week about how can we use the large language models and what's around it. So, but basically, if I want it to like if I wanted to create some structure for me that I can then translate into some code or just create me a code, it can. So basically, the idea is name me all the months names with some instructions. Some of them should be in Ukrainian, some of them should be in reverse order, some of them should be in camel case, but you shall give me it as the JSON object, as a dictionary. And it gave me. And basically, these texts can be automatically transformed into code and used in next steps of my code. Why not? So this one is a brilliant example how can we like use LLMs in industry. Next one. Basically, based on this, we can let's review one of the real prompts. This prompt is a little bit changed from what it was in a production, but nevertheless, the idea of this prompt is the following. Imagine I want to create a tool that books me a table in a restaurant, and I want to have it as a chat, and I want just like imagine it will be my assistant. I will call it or type it, and I say, "Hey Friday, book me a place, please," and it will book. But we have to explain the LLM what we want from it. And in this case, this is a real prompt, and I mapped it with the different colors. And right now, here you can see you are a smart named entity recognition tool. So this one is just some not a context but explanation of what it is. As like you are a 10 years old girl or whatever. Right now, if you put this one, it will act. It will understand what should it do. Then I explain some ideas. I will provide you with some definitions of entities that you need to extract from sentences. Um, I will provide you the output format. I will provide you the example. Your task is to extract entities, and your task to extract them as a JSON. Now I say entities. My idea is when I say just book me a place, I have a script that books this place, but this script has some parameters: where, when, for whom, and so on. So I have some entities like who, a person, for me, for my wife, and place, where, which particular restaurant. Uh, Resource. So basically, it's a table or room or I don't know, a bar, whatever. When, date, time. So basically, date and time we can split, we can merge. And some extra information. Maybe I want outside, or I want a vegetable, or I don't want to smoke, and etc. etc. So now I put the output format. Why did I give the entity definition? Because typically, if I say just a person, it will understand the person by itself. But right now, I have exact entity and maybe this place or resource. What is resource? From the Wikipedia, the resource is that. But I think I consider the resource is a table, room, or something else. So resource, I need to specify. So that's why it will use this explanation rather than Wikipedia explanation. Now this is the format, and I typically give the examples. More examples I give, more accurate I have. I become. So if I do not give examples, it's called zero shot. Oh no, go back. If I do not, if I do, it is like preheated prompt. And then I say, this is a sentence. So I will put my question here and the output. You see, there is blank. So there are nothing. And I expect that the LLM will continue all my text, and it will. And basically, given this output, it will give some context that you have to start your answer right here. So here, this is the prompt that we used in our some of the projects, and this is the result. So this is my sentence. So up there, like all that prompt, I consider it out there, so to the top. So this is just a sentence and output. Mary and I want some China food. Could you book us a table for two in the Golden Dragon restaurant tonight? Let it be a quiet place. And this is the answer. You see, I asked it not to give explanations. I asked it just to give the JSON format, and it gave me. The person, Mary, and I, place, Golden Dragon, resource, table for two, and so on and so forth. And I can easily translate it into next my future iteration of code. So this is the example of well-structured prompt, of how well-structured prompt appeared to become a well-structured answer. So having like when you start using prompts, when you start using the LLM, you will become in a future, like in some time, you will understand how does it work. You understand like different models. They might require different types of prompts based on the depth of the model, based on the lots of internal model parameters. However, each model can be fine-tuned with a prompt to have the good correct answer. I think I explained everything that I wanted to explain, basically from the perspective of more like user, less than like more than the engineer who works with that. Because first, when you try to create something based on some tool, like here we have GPT LLM, we need to understand how does it work as a user, and then apply this as the engineer. But as a postscriptum, I want to show you something. I like to have such kind of screenshots. I have a big collection of such kind of screenshots. However, the more the bigger models become, the less such kind of screenshots I can do. So the screenshot is this. So you shall never believe the LLM. You shall use it, but never believe, like, you shall always do not trust, just check and then trust. Like here, if you look at like this one, Mike's mom had 4 kids. 3 of them are Louis, Drake, and Matilda. Who is the fourth kid? It's obvious, it's Mike, but it said no, I don't know. So why is it? And the main idea of my today lecture is this. So the AI is not the intelligence. It's not the artificial intelligence. In our case, it's just a text generator. If you consider it as the very intellectual system with its own silicon brains and so on, unfortunately, it is not that. It is just a text. It generates text, and so far so good. And more data we feed in, the better it becomes. But no, it's not the intelligence. It's not the some kind of electrical person that can understand you. It doesn't understand you. It doesn't understand what is sound, what is each word. It just creates a text, creates a new token based on the token before, and that's all. Um, Thank you. So basically, I hope you enjoyed my small lecture. And basically, this is like not the lecture, but more like sharing on my own thoughts and my own experience with this. Whew.
Yeah, Roman, thank you very much for developing the topic in such straightforward and engaging way. I really enjoyed it, and I hope our participants also enjoyed. And yeah, we have 10 questions in the Q&A panel, and I kindly remind to all of our today's guests that if you want to put a question to the speaker, please text it in the Q&A panel. So
Uh,
I suppose we can move on to the questions.
yeah. Okay. I will read an answer. Basically, yeah. How does training work in machine learning? That's a very complicated question. I will let me just maybe answer it in a few words. I will try. Um, so I said that the model is the mathematical formula. Imagine the formula you have a multiplied by x plus b equals something. Yes, this is a very, very simple formula. Uh, and you want to fine-tune this formula to have the answer. When you put the x, you will always have the right correct y. But the problem is we don't have a and b, and we need to somehow to find them. And we start them with, let's say, with some zeros or ones or whatever, with some random numbers, and then we put next. Let's say we have a formula. A is 1 and b is 2. So it's x multiplied by 1 plus 2 equals y. So in this case, when we put something like 5 instead of x, the result will be 7. It's okay. Within few iterations, we will understand what is A, what is B, just immediately, because this is a very simple formula. However, the reality is not so simple. The formula might be very, very big, very, very complicated, and the relationships might not be straightforward, linear. There might be some noise, and they might not be exact results like 5 plus 2 equals 7, but 5 plus something equals 7.2, and next one 5 plus something equals 7.5. So two similar x's and different y's. So that's why it's a complicated process to finding these parameters of formula and basically finding the formula. And every time you add new part of the data, the formula is updated according to the new data. It's like when you or imagine it as you are a student in a school and you started doing the math, and the teacher says 2 plus 2 equals 4. How? I know. 3 plus 3 equals 6. The teacher doesn't explain why, but having a lot of such kind of examples, you might understand the relationship between them. Is it okay? Um,
We hope so.
I hope so. Okay, next one. Should the creators of the Gen AI program it to create watermarked content, both visible and hidden, to mark the generated image, text, sound? Oh, uh, they may. So basically, all that we generate and share with someone can be like arguably uh, belong to us or belong to the humanity. So it's like when you create your YouTube video, you can put your watermarks, and it means that no one will use this. Uh, so it depends on what are your purposes. There are no laws right now, general laws that say you have to mark your image as if it's a or uh, or it's a human or it belongs to that. There is no law. Some countries want to do this, but there is no such a law. Uh, I may say that there are some techniques, and basically there are some neural networks they can understand if it was created by a human or created by a person. These kind of algorithms they use in a GANs, generative adversarial networks. So basically, from a legal perspective, we shouldn't. If you want, you can, but it is right now. I don't see that we need this. Okay, so at embedding, each category can be taken as a dimension. It is because basically embedding is the representation of the word as a vector, and the vector has dimensions. So from linear algebra, we have a vector, yes, and okay, let's say we have a vector xyz, a 1, 2, 3, I don't know, and you can plot this vector in a 3D space. Yes, if you have 1000, the length of vector is 1000, you can plot it in a 1000D space. Why not? So I would say dimension is just a term, a mathematical term, nothing more. You just need to know that this vector is like this much long, and each step explains some feature of this word. Does temperature vary 0 to 1? So the smaller it is, bigger the bigger is the power that there is. It varies from 0 probably to possibly to infinity. However, like typically, usually people say use from 0 to 1. Yes, because 1 is the pure softmax without temperature. But you can use 2, you can use 3, but with 3, even with 4, this is the exponential growth. So even with 3, you will have just significantly here. With 3, you will see that all the tokens that you have, they will have exact probabilities. So, and it will be messy. It's not like from 0 to 1, but typically we use it from 0 to 1 because more than 1 is not so useless, so useful. It's useless. What what stands for what? Okay, V. Okay, got it. This is all the possible results that let's say when you create a text here, yes, in this case, V is 3. So we found 3 possibilities with different, like, we got 3 possible outputs. And V is the volume of all those outputs that we can apply. And you see this J, this I, so we iterate, so this is the this is the probability of this particular token to be presented as the next token. And now we iterate through over this all V, and this is a sum of all parameters of all these words that can be considered as the next token. And for each of them, we have this formula. So V is just all that words that we can use. So the vector of, let's go there, here. So the vector of 15 plus 27 means that it is very close to the vector of 42, yes. And that is why it predicts that as the answer. Yes, right. Um, yes, right. However, it doesn't go directly to this vector space and searches for the similarity. It has some formula behind. So it considers the distance between words for sure. However, you see, there are two words, three tokens. This one, and this one. And basically plus, when you use the vector of plus and vector of 42, they are quite far from each other because they are different different objects, yes? It's more like we use the embedding vector of this, vector of this, vector of this, apply some great huge formula, this so-called model, yes? And this model calculates the output of this context and tries to figure out the closest vector to this. So in general, yes, but it's not so simple. What about older text generative applications like Siri or Google Assistant? Did they use the same idea, tokenization? Uh, no. Oh, yes and no. Tokenization, yes. Let's say if we talk about Siri or Google Assistant, they convert the sound into a text and then work with text as it was previously. Right now, they do not convert it into a text. They use a sound-based models, and these models use the same embeddings. So the sound equals as the vector equals the sound mother or something like that. So right now they don't transform. Previously, yes, they transformed the sound into a text, and then they didn't use the vectorization or LLMs or something like that. Instead, they used like if you remember the Google Translate 4 years ago, it was horrible thing. It used the previous word, uh, let's say, to predict next word, and it was based on statistics. Let's say the word like fluffy and kitty appeared to be very frequent, and the prediction of the kitty after the fluffy was very high, and they just put it. They tried to have a context window, but again, it was typically it was based on the some predefined rules, some rules of English. So for each language, they had lots of rules, um, and yeah. So and basically, Siri understood your voice and basically Google Assistant based on some words. When you say turn on or music, it's a trigger word. Everything else is neglectable. Just music. Okay, I'll go to the music. So they searched for some particular okay, tokens, let's call it tokens to be act on. Uh I believe right now, oh yes, Google Assistant, I believe they tried uh, um I believe they all use right now LLMs under the hood, but previously it was not that. You showed how every word is valued, but how is the sentence or its part valued? Okay, cool. Is there a list of common phrases? No, no, no. Again, it's a very simple, typical idea. Oh, sorry. We have a vector of one word. And I say mankin, let's say, or man, I don't know, let's say embedded in vectorization, two words. Yes, I have one vector. I have another vector. And linear algebra allows us to have the vectors, the sum of the or average vector of it. And let's say having a text, we do not have a vector for this text from scratch using the same idea, but instead we create a vector of this text based on vectors of all the words inside of it that belong to this text. By some logic, maybe it's a average, or maybe it's like some formulas. But from linear algebra, you can definitely find the average vector of all the vectors. Why not? And this will represent your text. And let's say, and if the text has one word that doesn't belong to this text, let's say some typo, this typo will not affect all the rest vectors, and the average vector of the text will be close to all these words that belong to this text rather than this outlier. Does this style on the style one sorry it's jumps. Does the style one person speaks with the chat influence the way it speaks with the others? When we talk about chat and we talk about LLMs, it's a different things, because the chatbot, let's say, or the chat GPT is a large language model, and it has lots of instructions around. If you ask, let's go here. I will show you. Here it is. You see, tell me a joke about a man. It will give you a joke about a man, and tell me a joke about a woman. I'm sorry, I'm not programmed to do this. Why it is so? Because around of the chat GPT, around of the GPT model, there are lots of instructions, and some of these instructions say that do not joke about like Afro-Americans or whatever. And this is the extra information. And basically, the chat GPT, it has the prompt that says, instruction that says, be polite with all the users. Even the user is the jerk. So, however, if you talk to directly to the LLM without all that prompts, it will answer you as you speak. So if you say some rude words, it will answer with the same tone. Why? Because it just continues your text. And after your rude word, the probability of appearance of the another rude word is a very, very high. That's why it will speak with you with in the same manner. So talking about LLMs, yes, it will. Talking about chats, it depends on how do you do this chat. Are other AI tools, neural networks, also use tokens? Basically, in our case, tokens are not what we put into the LLM or neural network. Numbers, we put numbers. So here we have this input as the text, and we split it into tokens, and then we represent these tokens as numbers here. If we talk about images, we represent pixels as numbers. If we talk about voice, we represent the modulation, the frequency, and so on, all that stuff as the numerical representation. So we do not use tokens, we use numbers. And there is no way how can you use something. Okay, it's not the best formula, but again, how can you put the word into the mathematical formula? It's ridiculous. So that's why all the mathematical, sorry, or not, all the neural networks, by neural networks I mean mathematical models, they use math, they use numbers. Why we should use AI if it is only intelligent system? It depends on us. Why? Again, I widely use the ChatGPT because I want to make my letters, let's say, faster, create my letters. It helps me to understand something and so on. It is a tool that that can chew something in some information for you, or explain some information for you, or give some thoughts, or it can help you create uh, scripts based on this. So yeah, so imagine I want to process. So basically, the idea of using the LLM right now, I'm talking about LLM, but again, we can represent it as AI as the part of the process, the natural language processing, when you translate the language something into further steps, and you can use those further steps in your programs. Like here, yes, I created this, and then I converted this into something that I can use for in the future. It is the purpose of this intelligent system. And unfortunately, answering the similar question, uh, can we wait for the AI, real AI? The answer is having the same idea that we have, having the same architecture of neural networks right now, we will not have the real AI. We need to make the revolution of the architecture that we use. Even having the architecture that we have so far, brilliant architecture that helps us with all that, it is not the way how can we create the real AI. Okay, I see. Oh, there are lots of. I see that input to AI. Oh, jumps. I see that input to AI with context, details, and requirements is not really less than result. It could be get by another way even quicker. What is the benefit? What LM to go? I Sorry, I didn't get the question. I see that input to AI with context, details, and requirements is not really less than. It could be get by another way even quicker. I don't know this way. Basically, if you just want to ask a question about some interesting stuff from Wikipedia, it will explain. But if you uh, want the system to uh, act stable. So the main problem in using LLMs in real systems is that they are not stable. When you ask a question, let's say if I say, give me please the JSON with this, it will give the JSON in this format. Next time it will give the JSON in the next format. And you don't have this consistent format. And you have explained a lot how, what do you want, give a lot of information to the LLM, and then the LLM may be useful for you, and you can then process millions of questions in a minute or in an hour and get the results. So the purpose of AI in this case, yes, I know that we spent a lot of time, a lot of tokens on this prompt. However, when we do this, when we fine tune it, it becomes a good tool to obtain what we want. Or we can put some, I don't know, some students or people on another side of the chatbot to answer the questions. Why not? What is the procedure for preparing a digital presentation, and who does it now? The procedure is for LLM, the procedure is this. There is a model called embedding model or embedder. This is a simple separate model that takes a you create by yourself. So typically, if you want to create your own from LLM from scratch, you need to create your own embedder. You need to mark the data. You have to prepare the data. You have to create a huge, incredibly huge data set with all that embeddings, and you have to train the model, embedding model that will represent the tokens into this. And then, so you have to create the, let's say, vocabulary. And then this embedding model will automatically translate your text into this embedding. So yeah, this is it. And it's expensive. So OpenAI, they use their own embedding and basically for their purposes, and you can use the embedding and pay for this usage. Why not? This is again like if you want your own LLM to be created, you can pay them for their embedder because it's a effort, big effort. I would probably compare the learning process to hot and cold game. Um, uh, I like to compare it with the teaching when you really a student and you want to teach math, and basically there is a it depends on, let's say, data. If the data is bad, it's the same as teacher trains students on some kind of like 2 plus 2, 3 plus 3, and on the exam the teacher gives slides like 44 plus million, something like that. So something that people never saw, or multiplication. So it's a real learning. It's a really when you train a model, it's really as you train a small person, really. But again, hot and cold, maybe yes. It's a I believe it's a more like gesture, but nevertheless, uh, first of all, oh yes, it's in hot and cold. Yes, I'm agree. Question about AI and IT. It's a lot of talk about AI like a tool in IT, but it looks like something bad and dangerous. Text generative AI learning by a database based on open source projects, and it can have vulnerabilities and unclear code. Yes. As I said, what do you think of it? As I said, we shall not trust from scratch to the LLM, to the outputs. We need to check. If we talk about some very simple processes like convert this text into this text, or I don't know, give some spaces after words or something like that, it is simple. We can trust it, especially if we like the process of creation the prompts, especially like this. We have to spend some time with matrices, comparing the results with the with uh, mm, matrices of results of these prompts, based on these prompts, and then understand which part of the prompt gives less accurate and so on and so forth. But nevertheless, you obtain this result. And then you can receive this good result, and it will be stable. But if you want to have, let's say, a text generation, you may consider that it may have some noise and misunderstandings and so on and so forth. You need to worry about the accuracy. Yes, and I may say that all the machine learning stuff that we have so far, it is a probabilistic, and all the machine learning that we have so far is prone to problems. It is not 100% accurate. And I would say that right now, nowadays, the models like GPT-4 is as accurate as average person, typically. Not like by average person, I mean average person may have typos. Average person may lose their attention and so on and so forth. So it is the same as to trust people so far. Thank you for the informative lecture. When it comes to prompt engineering for generative AI, I'm curious about the role of specificity. How do we strike a balance between providing enough detail in our prompts to guide AI effectively while avoiding okay. When we talk about okay, the idea is how can we understand that this is enough, or it is overcomplicated. We can't just play with it. There is a process when you have to like consider it as an experiment. every time you change something in experiment, you have to write down the results of the experiment and then compare these results with the previous results. Yes, and we have lots of matrices. So we apply some matrices, some mathematical formulas to obtain some number. Yeah, basically, when I have this response, I may compare it with the response that I want to have. Let's say yes, and with some ideas, I can have, let's say, number one or 100% or whatever, some score. And I can track if I add something to this prompt, will my score change and where? And if I add something more, will it change significantly or it will just change insignificantly? So this is why data scientist is called scientist, because we do a lot of experiments. And this is experiment as well. When you tune something, and then you apply it to multiple, like hundreds of texts, and apply the same metrics to hundreds of texts and see the average metric. And if the average metric or variation of this metric is good, you may consider that this prompt will give you this type of text with this type of accuracy, and so on. Okay, can we unite different models between them with certain relation and mix together generated models? Okay, a number of specific models. Okay, yes, we can, but this is the question to my next topic, next lecture, next week. So yes, we can, but not like mixing the formulas. It's like creating a script that takes the output from one and puts the result to another. I see two more. Oh, cool. Do LLMs predict words in the output in the same order as they appear in the sentence? For example, if I ask, what flowers should I buy for my mom's birthday? And possible answer, you should buy red roses. Does it predict red before predicting roses? Oh, why not? Uh, Basically, it depends on like how it was trained. It was trained on the millions documents from internet, and yes, there are yes, as the anecdote, yes, there are lots of red roses in those documents, and the probability of having red roses, but rather than roses red, is bigger because like um red, green, and the adjectives. Yes, am I right? And basically they should be before everything else in English, let's say. And typically in documents you see the same pattern, and that's why it says I have to paste the adjective before everything else. So yes, it will give the red, not because it learns, but because there is a pattern of that. Okay, and the last one, do we really need real AI? All the things that are shown in films about yes. Uh, I'm relatively old person, and I saw lots of movies. I love movies of 80s, and there are two types of AIs. Uh, Three types of AIs. The first type is Skynet and all that wants to punish us. The second one is something like I don't know, 2 years old, 200 years old person, a man, the AI that wants to live with us as a living being, and the last one is the Friday of Iron Man that helps us. And I really believe that this one will be the last one that will help us. Um, uh, the difference between current AI and uh, a person is that the AI doesn't know what is abstraction. Uh, it doesn't understand what is sun. It knows the explanation of what is sun, but as an abstraction, what is yellow? Do you know what is yellow? Can you explain? And when the AI will understand what is yellow and will understand what is the abstraction and use the abstraction, it will be the AI. And do we really need it? 200 years ago, when the revolution came, industrial revolution, lots of people said that we don't need this because we will have no job because of all those plans. However, people do have jobs. And basically, yes, I'm scared of that my job will be replaced with this one. However, there are lots of other jobs that can't be replaced by this one. And basically, I will explain it in the future in my next lecture why, like next, I don't know, 10 years, we can be not afraid of that. Okay. Are there any questions? No?
No, thank you, Roman, for answering all the questions. And you know what? You made it in time. It's really cool. And thank you for the resourceful lecture. I hope that everyone found it engaging. So, a few words regarding what next. And next, if you have any questions or proposals, please text us and find us via email on this slide. And also, if you want to receive announcements for our future educational initiatives, please use this QR code and fill in pre-registration form, and then you will get invitations for our future initiatives. And also, we are inviting you for our next lecture, which will occur the next week on Tuesday. And if you enjoyed Roman's today's webinar, also we invite you on Wednesday to Roman's chatbot building live coding webinar. I think it will be very interesting. So thank you all for your time and for your interest in GlobalLogic Education Services, and see you the next lecture. Bye-bye.
Thank you. Cheers.
Thank you. Thank you all. Thank you all. Many thanks in the chat. Bye-bye.